So we finished doing our exponents review, and now we're ready to do uh, some work with some exponents, right? There are a couple different things that make working with exponents easier, and that's what this lesson is all about. So teaching you some of those ways to make working with exponents easier. We call them rules, um, but you'll see what I mean here once we start going through these. So first says the product rule. Now we know that word product in math means to multiply, right? So we're going to multiply these numbers that have exponents attached to them. It says write the two expressions in expanded form for the first way. So what that means is I can write out 2 cubed as 2 times 2 times 2, and 2 to the power of 6 or 2 to the 6th power as, using 2 6 times. So 1, 2, 3, 4, 5, 6. And since the only operation is multiplication, really I can just count up how many 2's there are, right? So I count there's 1. I'll mark them off here just to make it more obvious what I'm doing here as I count them. So 1, 2, 3, 4, 5, 6, 7, 8. There are 9 2's being used there. So 2 is being multiplied by itself 9 times, right? Okay. Another way is to use the base product rule. Oh, sorry. Now you try it. We've got 4 cubed times 4 to the power of 7, or 4 to the 7th power. So you guessed it. I'm just going to do it with you. It's going to be 4 times 4 times 4, right? Use that 4 3 times. That's what 4 to the power of 3 means. Times 4 to the power of 7. So use 4 7 times. So 1, 2, 3, 4, 5, 6, and 7. And then just count them up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I count 10 4. So, I forgot to actually write my answer. Jeez, what is going on? I forgot to write my answer for the other one. So it's 2 to the power of 9, right? Because 2 is multiplied by itself 9 times. And then it's 4 to the power of 10 because 4 is being used 10 times, right? The other way, let's get to this one, is to use the base product rule. So the base product rule says that you can just add the exponents when you're multiplying matching bases. So that's what we're going to fill in the blank with here. Okay. In other words, when we're multiplying two numbers that have the same base, I can really just add their exponents. And that's how I get 2 to the power of 9, right? So it works the same way here. It says you're supposed to try this one. Well, I'll do it with you, okay? 4 is the base. They both have a base of 4. That means I can just add their exponents. And 3 plus 7 gets us that 10, which is what we got writing it out in the expanded form. But this was way easier, right? So we'll practice some problems like that here in just a minute. The power rule says you're raising something that already has an exponent to another exponent, right? So it's a power raised to another power. So one way is to write the expression in an expanded form. So again, when we have those parentheses, and we learned this in our review, the number that's outside of the parentheses, the exponent, sorry, that's outside the parentheses is saying that everything inside the parentheses is the base. So when it says 7 squared is raised to the power of 4, that means you're using 7 squared 4 times. So I'm going to write that out. 7 squared times 7 squared times 7 squared times 7 squared. So I use 7 squared 4 times, right? Well, that can be broken down even further, right? I can expand that even further, because 7 squared is 7 times 7, and then 7 times 7, and then 7 times 7, and then 7 times 7, right? We know to square something means to multiply it by itself. So those are all multiplication symbols between all of those. And when I count those up, you see 7 is being multiplied by itself 2, 4, 6, 8 times, right? So my answer is just 7 to the power of 8. And then it says, now you try. So you would try that with 6 cubed raised to the power of 5. So we're using 6 cubed 5 times, right? I'm going to do this one with you. So that's the same thing as saying 6 cubed times 6 cubed times 6 cubed times 6 cubed times 6 cubed. All right, so I've used 6 cubed 5 times. But that can be expanded even further because 6 cubed is really, 6 times 6 times 6. Let's fill all these out so there's not just 3 6s. And then I've got 6 cubed again, so times 6 times 6 times 6. And then 6 cubed again, so it's times 6 times 6 times 6. And then 6 cubed again, so times 6 times 6 times 6. And then one more time. 6 cubed is 6 times 6 times 6. You count up all of those 6s. I count 3, 6, 9, 12, 15 6s. So it's 6 to the power of 15, right? The other way, so the rule that we're going to learn is, it says use the powers to a power rule that says that you can, and I'm sure you guys have probably realized this by now, but multiply. Multiply the powers when there is a higher power. So when you see an exponent being raised to another exponent, multiply the exponents together and keep the base the same. So when it says 7 squared raised to the power of 4, that's really saying that I can take those exponents and multiply them together, 2 times 4, and that's how I get my 7 to the power of 8. And then the same thing works for 6 cubed being raised to the power of 5. So it's really 6 raised to the power of 3 times 5, and 3 times 5 is 15. You can see how when we start using a little bit larger numbers, this rule really is going to be useful. You don't want to write out all those expanded forms when we're using larger exponents like 8 or 9. What if this was 6 to the power of 8 and that whole thing was raised to the power of 9, right? That would be, well, that would be 72 6s. You don't want to write those out, right? So that using these rules, it's just a way to help you work with exponents more easily, okay? Turn to the next page. The next rule that we're going to talk about is the quotient rule. And you guys know quotient means answer to a division problem. So we're going to talk about what to do when we're dividing exponents. So here it says one way, again, is to write them out in expanded form and cancel out the pairs. So I've got 5 to the power of 7 divided by 5 to the power of 3. Well, look what happens here. So I've got 5 to the power of 7 in expanded form is 1, 2, 3, 4, 5, 6, 7. Whew. So I've got 7 5s, right? All multiplication. On the bottom, 5 cubed, so divided by 5 cubed. So I've got 5 times 5 times 5, right? I can cancel out pairs, right? If I have the same thing in the numerator that I have in the denominator, those cancel each other out. So here I've got boom, boom. Those cancel each other out. 2 more cancel each other out, and then the last 2 that cancel each other out. Well, what am I left with? I'm left with nothing on the bottom, right? Those all, when we say cancel out, they really simplify to 1, right? 5 divided by 5 is 1. So really, I just have a 1 on the bottom. Well, that's, dividing by 1 doesn't change it. So really, this is just 5 times 5 times 5 times 5, or 5 to the power of 4, right? I can put that over 1 if it helps you to think about it, so you know that there's a 1 there still. But dividing by 1 doesn't change the value of it, so I'm just going to leave it as 5 to the power of 4. All right. So another example is when the bigger exponent's on the bottom. So look and see what happens here. So 3 to the power of 6 is 1, 2, 3, 4, 5, and 6. So I've got 6 3s on the top, all multiplication, right? 3 to the power of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. a lot of 3's. And then the pairs cancel each other out. I mean, really, they simplify to 1, and you're going to see why that's important here in just a second. So that's gone, that's gone, that's gone, that's gone, that's gone, that's gone. These two, gone. Next one's gone. These two, gone. And I'm left with 3 to the power of 4 on the bottom, but what's on top, right? Well, that's why we said when they cancel out, they don't really cancel out, they just simplify to 1. So really, that's just a 1 on top. And then it's 3 to the power of 4 on the bottom. Okay, so he says, now you try it. And I'm sure you guys probably see the rule now, but let's do it anyway. So 3 to the power of 8 is 1, 2, 3, 4, 5, 6, 7, and 8 3's on top. Only 3 3's on the bottom. Change to different color so I can cancel out my pairs. So the 3's, 1, those 2 cancel out, those 2 cancel out, and those 2 cancel out. I'm left with, how many is that? 1, 2, 3, 4, 5 3's on top. So it's 3 to the power of 5 on top. And I can put that over 1. I mean, you could put that over 1, but dividing by 1 doesn't change the value. So I'm just going to leave it as 3 to the power of 5. And then for these 8's, same idea, right? So I've got 1, 2, 3, 4 8's on top, all multiplication. 8 to the power of 4 is 4 8's being multiplied together, right? And then 8 to the power of 7, so I've got, I'm going to need a longer fraction bar. We've got 1, 2, 3, 4, 5, 6, and 7. And I'll change color so I can cross out my pairs. 8 over 8, that simplifies to 1. That simplifies to 1. That simplifies to 1. And that simplifies to 1. So I say that because, now we have the 1 on top, and then 8 times 8 times 8 on the bottom is 8 to the power of 3, or 8 cubed. Okay, so I know some of you probably see what the rule is going to be here already. Basically, if I'm dividing numbers where the bases are the same and they both have exponents, my shortcut or my rule says I can subtract the exponents. Okay, so 5 to the power of 7 divided by 5 to the power of 3, the shortcut or the rule for that would have been to just subtract the exponents, and that's how I get 5 to the power of 4. You can still see that actually on my screen. So 5 to the power of 4 is what we got before, right? All right, so example, for this other example, when we had 3 to the power of 6 divided by 3 to the power of 10, you guys saw what happened, right? I had the 1 on the top, and it just says always blank from the larger number. Just always subtract from the larger number. It does take a little bit of thought on your part, though, to look and see. If the bigger number is on the bottom, that's why they put that 1 on top. We know all of the ones on the top are going to cancel out. So it does take a little bit of thought on your part. Look and see, where is the bigger number? If it's on the top, then your answer is just a regular exponent with a base, right? If the bigger exponent's on the bottom, that's when it's going to be a 1 on top. Your answer is actually going to be part of a fraction, right? So then I'm going to do, still 10 minus 6. 10 minus 6 is 4, so I have 3 to the power of 4. 1 over 3 to the power of 4, sorry. Okay, now you try these ones. I'll just go ahead and do them with you. 3 to the power of 8 divided by 3 to the power of 3, they have the same base, so I can just subtract their exponents. 8 minus 3 is 5. And when I look over, yeah, that is what we got, right? 3 to the power of 5. Now, 8 to the power of 4 divided by 8 to the power of 7. Oh, I notice bigger exponents on the bottom. So I'm going to put this under 1 and then just do the same thing. 7 minus 4, and that's going to equal 1 over 8 to the power of 3. When I look over, it's what we got when we did it the expanded format way. Okay, so you guys are going to try out those 3 rules. So when I'm multiplying 2 numbers together that have the same base, I can add their exponents. When I am looking at an exponent being raised to another exponent, so a power to a power, I multiply those exponents. And when I'm dividing 2 numbers that have the same base, I can subtract their exponents. All right, let your teacher know if you have any questions.